In this tutorial, we will talk about using the mmeta function for data involving continuous outcomes, and we'll do this by working through an example. The standard model for continuous data is the bivariate random effects model, and more details about this model can be described in the references at the end of this section. Specifically, you can refer to the paper published in 2015 called An Alternative Pseudo-Likelihood Method for Multivariate Random Effects Meta-Analysis. The main insights for multivariate random effects meta-analysis can be found here. And as we can see, the parameters of interest are beta 1, beta 2, tau 1, and tau 2, and these correspond with the underlying pooled effects and between study heterogeneity. Now before we go into typing the command, I just want to note that for continuous variables, there are 4 estimation methods that you can choose from. They are nn.reml, nn.cl, nn.mom, and nn.rs. The NN refers to the bivariate random effects meta-analysis model. REML stands for restricted maximum likelihood, CL for composite likelihood, MOM for movement of method, and RS refers to the improved method for the Riley model, and these are described in further detail here. Now if you choose continuous for data type but use a different method than the ones just mentioned, R will return an error message. Now let's get to the data. First, make sure you have the mmeta package installed in R. The package contains sample data that we can work with. For this tutorial, we'll use the dataset titled prostate, and to access this data, we just run the command data and in parentheses prostate. And we can take a look at the first few lines of the dataset by running this command. As we can see, there are 4 columns of data here. The Y1 and Y2 columns list the effect sizes for 2 outcomes, while the S1 and S2 columns are the corresponding standard errors. Since our prostate dataset does not include a value for rho, we can only run the function using the nncl and nn.mom methods because these estimation methods for continuous outcomes do not require rho. Now let's go ahead and type our command. First, let's label our command fit.nn. And we'll scroll up to the usage section over here to see how the command is structured. Following this format, we type mmeta, and then in parentheses we type in the name of our dataset, which is prostate in this case. The type of data that we're working with is continuous. K is 2, and for the sake of this example, let's use the nn.cl method. So now let's run this command, and we can see the output by typing summary and in parentheses the name of the command. Now looking at the summary of results, we can see that the first 3 rows here are the inputs for data type, estimation method, and number of K outcomes. And these we specified in the function. The fixed effect coefficients return beta 1 and beta 2 values, and these are the underlying pooled effects that we are interested in. Between study variances, or the tau 1 squared and tau 2 squared values, are the between study heterogeneity. Finally, the last component of the output is the covariance matrix for the parameters calculated by the mmeta function.